In this session, we're going to see how to identify conic sections just by looking at their equations. I'm not going to go through analyzing the graphs of all of these things because those are in other videos. This is just if you have a hodgepodge of equations, you need to identify what it is so you know whether you're looking for asymptotes, whether you're looking for a directrix, or simply a major axis for an ellipse, that sort of thing. This will just kind of point you in the right direction. So the general form of the equation of a conic section is ax squared plus by squared plus dx plus ey plus f is equal to 0. Right now you may be going, where's c? C would show up, it would be like cxy, and in that case you end up with parabolas that aren't horizontally or vertically oriented, but are, kind of twisted, turned, rotated actually off to this side. Or you might have an ellipse that is likewise rotated. It's the xy term that makes those rotated, and that's a whole different topic. We aren't going to go there right now. Where we are going to go is how to use this form to recognize what we're looking at. Check it out. If either a or b is 0, in which case you have only, say, an x squared term or only a y squared term, then what you have is a parabola. So if either x squared or y squared is missing, then you have a parabola, provided you have the other y squared or x squared respectively. If it turns out that a and b are the same number, then you have a circle. Well, okay, things could work out so you have just a point or nothing at all, and I'll talk about that in a few minutes, but generally speaking, if a is the same as b, then you probably have a circle. If a and b are not the same, but they're both the same sign, the way we're going to write that is we're going to say if the product of a and b is positive, right? So if they're both positive or if they're both negative, then when you multiply them together, we won't be multiplying them together. It's just an easy way to say if a and b have the same sign, but they're different, then you have an ellipse. And then finally, if a and b, the coefficients of the x squared and y squared terms, are of opposite sign. Well, let's just pause for a moment and say, if they're of opposite sign, when I multiply them together, they'll be negative. Again, we're not going to be multiplying them together. It's just an easy way to say if they have opposite signs. Then you have a hyperbola. Now, so, okay, weird things can happen, but I'll let you know how to look for that as well. Let's identify conic sections given by various equations. Our first customer, 4y squared plus 3x minus 16y plus 19 is equal to 0. I notice that I have a y squared term. Check. I notice I don't have an x squared term. That means we have a parabola. Yeah, you can tell the equation of a parabola that directly. And furthermore, because the squared term is the y squared, I know that it's going to be horizontally oriented, right? So it's going to open left or it's going to open right. If we put y squared and x on opposite sides, then we would see that it actually is going to be the case that this particular parabola opens left. Now that I know I'm looking for a parabola, I know what form I want to put the equation in, and so I would maybe factor the 4 out of the y terms, y squared, after lumping them together. So I'd have 4 times the quantity of y squared minus 4y, and then maybe I'll subtract the 3x and the 19, moving them to the right-hand side, and then inside the parentheses, cut that negative 4 in half and square it, and then what did I really add? I really added 16, and so we end up with like 4 times the quantity of y minus 2 squared is equal to negative 3 x minus 3, and then maybe I want to, I don't know, there are various forms, as you recall, for writing these equations. Maybe I'll say we have 4 times the quantity of y minus 2 squared is equal to negative 3 times the quantity of x plus 1. And so maybe I'll divide both sides by negative 3 and then subtract 1. Maybe end up with x equals negative 4/3 times the quantity of y minus 2 squared minus 1. And then from there I can find the vertex and the focus and the axis of symmetry and the directrix. And then we would use all that information and draw a graph. I know that was kind of quick and just a little bit sloppy, but again, I'm just trying to help you to figure out how you can get pointed in the right direction. Next, we have 100y squared plus 4x equals x squared plus 104. Well, the first thing I'm going to do is I'm going to subtract x squared from both sides so that I end up with all of my stuff on the same side. All of my variables, I should say, not just stuff. On the same side, I have 100y squared minus x squared plus 4x is equal to 104. And now I see the coefficients of x squared and y squared are, well, y squared and x squared are 100 and negative 1, respectively. These are opposite signs. We have a hyperbola. And then, knowing that it's a hyperbola, I know that I want to have 1 on the right-hand side. So from the x terms, I'm going to factor out a negative 1, writing stuff in parentheses. So I have 100y squared minus the quantity of x squared minus 4x, leaving a space inside the parentheses equals 104. And then, of course, inside the parentheses, we're going to be adding 4. But what did I really add? I really added a negative 4, giving me 100y squared minus x minus 2, the quantity squared, equals 100. Dividing by 100 on both sides gives me y squared over 1 minus x minus 2, the quantity squared, over 10. 100 is equal to 1. And now I know that the center of the hyperbola is at 2, 0. And then I know that I need to find asymptotes, vertices, and foci. And then all those together help me to draw the graph. And I was able to identify what I needed based on the fact that it was a hyperbola. Next up, 5x squared plus 5y squared minus 125 is equal to 0. I notice that the coefficients of x squared and y squared are both 5, so we have a circle. Probably. Okay, this is where I'm going to let you know when things might get a little weird. First off, I see 5s everywhere. I'm going to divide by 5, so I have x squared plus y squared minus 25 is equal to 0, and then add 25 to both sides. X squared plus y squared is equal to 25, and now I know that this is a circle centered at the origin. Radius is 5, all good. Now, so let me write that down. Circle. And so you would want the radius and the center, and then you would draw the graph. Okay. Now, I'm going to change it up a little bit. Suppose it was originally 5x squared plus 5y squared plus 125 equals 0. Then dividing by 5 would give me x squared plus y squared plus 25 is equal to 0. Subtracting 25 from both sides would give me x squared plus y squared equals negative 25. This is nothing. There are not two real numbers that you can square and get a negative. Okay, so that's it. Suppose we had started out with, well, suppose we ended up with something like x squared plus y squared is equal to 0. In that case, we would have a single solitary point. That point would be 0, 0. Those are the, I mean, you square zeros and you add them together, you get 0, right? This is called a degenerate conic. And degenerate conics, you basically need to watch out for those if your right-hand side becomes 0 or a negative number. In the case of a hyperbola, you're pretty much going to have something unless it equals 0. But with an ellipse or a circle, because you're adding things that are squared, if the right-hand side is negative, you got nothing. So those are a couple weird things that can happen. Next, our equation is 4x squared plus y squared plus 8x minus 4y plus 4 equals 0. Gosh, that's a lot. Don't look at it all. Look at the x squared and y squared terms. 4x squared plus y squared. They have the same sign. They're different numbers. We have an ellipse. Now, it may be tempting to say, hey, I know which way it's oriented. On its side, on its end. No, not yet. What we would need to do to perform that analysis is I'm going to lump together the terms that contain x, so 4x squared plus 8x, and then I'll lump together the terms that contain y, so plus y squared minus 4y, and then I'm going to subtract 4 from both sides, so it equals negative 4. Then from the x terms, I'm going to factor out a 4, and that leaves me with x squared plus 2x in parentheses. Leave a space because we're going to complete the square, plus y squared minus 4y doesn't need parentheses because there was nothing to factor out. But I'm still going to leave a space, and that equals negative 4. And then inside the parentheses for the x terms, I'm going to add 1. But what did I really add? I really added 4. And then for the y terms, add 4. And then, of course, what I really added was 4. And so I have 4 times the quantity of x plus 1 squared plus the quantity of y minus 2 squared is equal to 4. Folks, if that 4 was negative, we'd have nothing. If it was 0, we'd have a degenerate conic. We're going to divide both sides by 4, though, and we have x plus 1, the quantity squared, if you like, over 1, plus y minus 2, the quantity squared, over 4 is equal to 1. And now I know that this is an ellipse that's basically a football on its end. And we have a center, vertices, foci, and if you're asked for them, the major axis and the minor axis. Okay, so, oh, and then of course, don't forget, we can graph the thing, right? In any case, that's how we can use inspection of the original equation to find out what kind of conic section we're after. Something I blew right past. What tells us we're looking for conic sections at all is the fact that we have x and or y's that are squared.